Number 7 says use trig sub to transform the integral dx over the square root of 16x squared plus 25 into a trig integral, then evaluate the trig integral in terms of theta. No need to trace back to the variable x. So this wants you to go through, solve the integral, but at the very end you don't need to convert back to your original variable x using the triangle. So when I take a look at this, it says we already need to use trig sub, so that narrows it down to exactly what we need. So I have 16x squared plus 25. There is a plus term in the middle, which tells me that my substitution in this case is going to be using tangent. I have a 16x squared, so I could potentially rewrite that as, if I want to write it as a quantity squared, because I do want like an x squared plus a squared, this would have to be 4x quantity squared, which would be 16x squared, plus 5 squared. So this is the term that I'm going to be setting equal to my trig function. And this is going to be my a term, which 25 is a squared, so square root of 25 is just 5. So this is the substitution I'm using in that case. And now I have to go through and take its derivative. 4 dx, don't forget that 4 does not derive out when you derive it, so you need to be careful, is equal to 5 secant squared theta d theta. Okay, so I noticed that I don't have a 4 dx, I just have a 4, so I'm going to go ahead and just divide that term over to compensate for it. So I have everything I need now. I can go through, plug everything in. So I have 5/4, I'm going to write on the outside, secant squared theta d theta. And here I have 25 tan squared theta plus 25. Okay. So now, when I go through, try to solve this, remember I'm trying to reduce it down. So I have 25 plus tan squared theta plus 25. So I can pull out a 25 for both of those terms. And I end up with a 5/4 on the outside still. I still have the secant squared theta, d theta term. If I pull out a 25 for both of those terms, I'm left with tan squared theta plus 1. Tan squared theta plus 1 is equal to secant squared theta. So I end up with the square root of 25 secant squared theta, which if I take the square root of that, I end up just getting 5 secant of theta. Okay, so now I can cancel some terms out. This 5 and this 5 cancel. This secant and this secant cancel. So it looks like I'm left with just a 1/4 integral of secant theta. I need to figure out a way to integrate secant theta. Well, secant theta does have an integral, and it was given to you in class, and the integral of that is 1/4 natural log of secant theta plus tangent theta. Let's see. So my final answer is 1/4 natural log of secant theta plus tangent theta. Now normally, I would need to convert back to x by using the triangle, but in this case, this is all you need to do because it says leave it in terms of theta. So 1/4 natural log of secant plus tangent is equal to your final answer, which is letter A.
The Teaching Center, UF's Learning Resource Center.